The following presentation is about a potato cannon project during our chemical application class. This is presented by Christina Akrazoglu, Holly Holst, and Kristen Cook. Preparations for the cannons. In a previous unit, we used bottle rockets to set up the idea of ignition and propulsion that we would later end up using for our potato cannon. For more information about this unit that we went over, we will direct you to a previous PowerPoint if you would like more information about that. Potato Cannons Part 1, Brainstorming. The concepts we covered were voltage and ignition. We measured the voltage, and there were multiple things that we wiggled here. The nail position, types of nails, coating of nails, and different sources of sparking. With our wiggle for the nail position, we were really excited about this idea. Before the nails were in the PVC pipe, it was really easy for us to change the position of these. So in the PVC pipe at about a 90-degree angle. But when we were practicing this, we put them at a 180-degree angle, so they were pointing right at each other. And the spark was really great here. It could travel a farther distance, and it was brighter. Unfortunately, we could not use this because it would ruin the integrity of the potato cannon. We also didn't end up trying this, but we brainstormed ideas of using different nails that have different materials that they used. We're not sure how this would have changed it. It could have changed it significantly or not at all. Coating of nails, which we actually ended up doing, and I'll go over in the next slide, and different sources of sparking. Areas of struggle, figuring out an accurate way to measure the strength of the spark. We tried to use a voltmeter, but it didn't end up working because it was a continuous spark. We also had trouble measuring the quote-unquote brightness of the spark because, as you can imagine, the human eye isn't as accurate, and it's also could be biased. So we really didn't have a good way to measure the brightness of the spark. Potato Cannon Part 2, testing one variable. We ended up coating, as previously said, we ended up coating the nails with different substances. We used water, soda, vegetable oil, and a water-based glue. We thought that these were good ideas, and our best idea that we thought we had was using the water just to coat the nails. We also thought maybe soda would be a good idea. We didn't know what the sugar content would do to change this. Vegetable oil was actually something we didn't think would hardly work at all, which turned out not to be true. And we also used the Rose Art glue just because we knew that the extensive use in elementary classrooms and how water-based it is. We just thought that water was our best guess, and this glue was very, very water-based. So we thought it might be also a good option. The results. We ended up measuring the spark by trying the switch 10 times to see if the spark would make a spark 10 times continuously. We also recorded the color and the brightness,
it sparked in a couple of different places like it did before.
To record this, but we also recorded how the spark crossed in between the nails. For this last one, it was interesting because with our most efficient coating products, which ended up being vegetable oil and the glue,
look how it goes.
There would be, instead of just a single line in between the two nails, it ended up being that the spark diverged at a certain point and hit the nail in two spots at the same time, which we thought was interesting and maybe indicative of a stronger spark. We recorded the brightness, which it was significantly brighter in our opinion with the oil and glue stick. However, as said before, this isn't something that we weighed too heavily on, but certainly the vegetable oil and glue made a continuous spark 10 times in a row. Potato cannon part 3, final product. Our potato cannon worked without the vegetable oil, but it hardly made it into the air. But when we did use vegetable oil, the cannon was much more successful. There was recoil in the cannon and expelled the potato into the air for about 8 to 10 seconds. Below is a video of our successful cannon. As you can see from the video, certainly the potato was expelled a good distance, which showed the force behind the spark. With other groups, we didn't see as much of the recoil, which we feel may indicate that our spark was more powerful or quote-unquote better. Applications in the classroom. This was a great experiment because it applies knowledge from multiple science concentrations. Chemistry and certainly physics was applied. Also, biology could definitely be applied, how certain sugars could maybe coat the product. It's a great experiment. It definitely covers a lot of different things. We also recommend breaking up the experiment as we did into multiple smaller experiments. This way the student can get familiar with the concepts of the cannon. It will overall help them to find more ways to get engaged with their open inquiries. Certainly when our group received the email that included pictures of the components of the cannon, it was a little confusing, and I'm glad that we got to practice just making a spark to see what was really going on inside the cannon. It gave you a bigger picture for what you were going to do. We also recommend the cannon part at least a week-long component with classroom work every day. Certainly more work would have been great, just so students could more trial and error shooting these potato cannons, working with other groups, and just getting more ideas. If their cannon wasn't successful, they can go back to the drawing board and try again. It was a really great experiment, definitely engaging for the students. I mean, it's a potato cannon. Of course, it's going to be fun, and a lot of good ideas from classmates to see what they were doing to engage other students.